Hi, welcome back to Physics Teacher, the channel that helps you prepare for the Waterloo math, physics, and chemistry contests. This is an example from the Euclid contest, which is a grade 12 math contest. Give it a try, and I'll be right back with the solution. So what we want to do is choose 5 distinct integers from this set of numbers 1 to 8 and place them into the top row. And we want to know how many different ways can we place these integers so that the bottom box is exactly this integer here. Alright, let's start with a little diagram here. Let's say we place the numbers A, B, C, D, and E. And as we go down, we multiply. So this box here would be the product of A and B, B and C, and so on, and we can continue to fill out our little pyramid here. And so now we know that this is equal to 9,953,280,000. Next, what we're going to do is split this number up into its prime factorization. So you can already see that this is on the order of 10 to the 4 with all these zeros here. So I'm going to write this as 10 to the power of 4 times by 995,328. Now 10 isn't a prime number, but we can rewrite that as 2 times 5. 10 is just 2 times 5. So 2 to the 4 times 5 to the 4. And then this number here is also divisible by 8, which is 2 to the 3. So if we divide that by 8, we get 124,416. This gives us 2 to the power of 7 times 5 to the 4. And you can check this is still divisible by 8, so we can pull out another 2 cubed. And that leaves us with 15,552. Alright, so reduces to 2 to the 10 times 5 to the 4. And again, divide by 8. And we're left with 1944. So now we have 2 to the 13, and we just continue 5 to the 4. And we can actually divide by 8 again. So when we do that, we're left with 243. So now we have 2 to the 16 times 5 to the 4. And 243 is just 3 to the power of 5. So let me just rearrange this in increasing order of our primes. So we have 2 to the 16, 3 to the 5, times 5 to the 4. So now it's going to be easier to choose our numbers. And if you look right here at our right side, you can clearly see this number is not divisible by 7. So we know that 7 is not going to be in our initial set. We can take that out. It will not be chosen. Then if you take a look at this last term here, 5 to the power of 4, the only number in our set which is divisible by 5 is 5 itself. So that means either B or D must be 5, because that would give us 5 to the power of 4. So let's look at 2 cases. So case 1, we are going to have B equal to 5. And case 2, we will have D equal to 5. Let's start working with case 1. So if B equals 5, then what we're left with is A. So we already know what B is. That means C to the 6, D to the 4 times E would be equal to just 2 to the 16 times 3 to the 5. Alright, so let's continue to break this one down. So as we continue to break it down, let's now look at the 3's. There's only 2 numbers in here that are divisible by 3, and that's 3 and 6. So this is going to lead us into a couple options. Either D is going to be 3, and A is going to be 6. Another option would be to use D as 3, because D is to the power of 4. And then since we're looking at something divisible by 3 to the power of 5, I can use A, like before, which is 1, but E is also to the power of 1, so I could have E as 6. And then I could also switch my 3's and 6's, so I could have D as 6 and A as 3, or I could have D as 6 and E as 3. So I have 4 possible options down this pathway. Let's work with this one. So if I have D as 3 and A as 6, I'm left with 6 for A times C to the power of 6 times D would be 3, so 3 to the power of 4 times E, which is 2 to the 16 times 3 to the 5. Now to cancel out 3 to the 5, what I'm going to do is I'm going to change the 6 2 times 3. So if I change it to be 2 times 3, then this 3 to the 4 times 3 to the 1 gives us 3 to the 5. And that'll cancel out here. And then notice if I divide both sides by 2, I'm left with C6 times E equals 2 to the power of 15. Alright, so now I'm left with 4 numbers in my set. 1, 2, 4, and 8, all of which could be either C or E. So this is going to take a little bit of trial and error. But with a little bit of trial and error, there's only one option, and that would be C as 4 and E as 8. So the numbers, one way for the numbers to work then, if we follow this first case here, would be 6, 5, 4, 3, 8. And you can follow this same method here to figure out what C and E are for these 3 values as well. And there's only one option for each. Give them a try and let me know what you get in the comments. And then if you go back and look at our case 2 at the very beginning, instead of saying B is 5, we say D is 5. Well, because this number is so symmetrical, 1, 4, 6, 4, 1, you end up getting, again, 4 different options. So you have a total of 8 possible ways you can rearrange this set with your distinct integers to get this final number at the bottom. Can you find these possibilities as well? Let me know in the comments.